Let us read this question now. What are the principal roles of moderator and a control rod in a thermal nuclear reactor? My dear students, I tell you, this question is actually a repeat telecast question for IB examinations. They are highly interested in moderator and the control rod. Again and again, you are going to see this question, and we are going to answer it in the similar manner. So even there was one question, a previous question. If you were watching those videos, you can watch the earlier videos. We have already discussed what is a moderator. Let me explain you once again. Moderator is a liquid, and the chamber where the nuclear fission process is taking place, it is filled with a liquid. Generally, this liquid is just like water. This is known as heavy water. So D is the deuterium, which is isotope of hydrogen. It's comparatively heavier than the normal hydrogen. That is why this is known as heavy water. So heavy water is used as a moderator, and its prime function is it's non-reactive. First of all, there is no reaction taking place. The neutron is moving at a very fast speed, but the neutron cannot be seized, cannot be captured by the uranium if it is moving at a very fast speed, because the neutron just bounce back and the uranium is not able to capture the neutron. So to facilitate this reaction, what we need to do, we need to do something that will reduce the speed of the neutron. So what happens is the fast moving neutron is going to collide with the molecule of heavy water. The kinetic energy of the neutron is now shared between the D2O molecule and the neutron, thereby reducing the kinetic energy with the neutron. That is what we wanted to do, and that will facilitate the seizure of the neutron by the uranium, thereby causing the nuclear fission reaction. So the answer will be reduces the kinetic energy of neutrons. So either C or D. Now, role of control rod. But control rod, what are control rods? I tell you, like this is the chamber. This is uranium rods. And what is the moderator? Moderator is kind of liquid that is filled into this space. This is moderator. So moderator is a liquid and the chamber is completely filled with it. So the only job is to reduce the velocity of neutron. What is happening with the control rods now? These are control rods here. They are added like this. These are control rods. And these control rods can move up and down. They can move up and down. The purpose is to control the production of neutron. Now, whenever a nuclear fission is taking place, it only needs one neutron, but it is going to produce two neutrons or three neutrons. Like if we go for barium plus krypton, then three new neutrons will be produced. Now, it's not final, like it's not guaranteed that only barium and krypton will be produced. It could be producing xenon and stradon. But if this is the reaction taking place, then two neutrons will be produced. So we cannot control the reaction. Whatever is the nuclear byproduct, it will be chosen by the uranium itself, like which are the things that they want to produce. So they are producing this. So in this reaction, three neutron, this reaction, two neutron. So this gives rise to an uncontrolled chain reaction. Like one neutron is able to produce three neutrons. This one neutron will be further producing three, further producing three, further producing three explosions. This is going to further produce three. It means one neutron, three, and then 9, and then 27, and then 81. So this is kind of uncontrolled nuclear fission reaction. And this is what happens in the case of fission bomb. But we do not want it in the case of nuclear power station. So what we do, we use the control rod, and the main purpose is to absorb the neutrons. To absorb the neutrons. And when it absorbs the neutron, it actually maintains a constant rate of reaction, isn't it? Like it is not allowing the nuclear reaction to go out of control. It is having only one neutron in each cycle. Only one neutron is allowed to react, and other neutrons, if they are produced ever, they are absorbed by the control rods. This is what is the purpose of a control rod. Moreover, if you want to switch off the nuclear power plant itself, you just push all the control rods into it, and the day will come. It takes time. The day will come when all of the neutrons are absorbed and the nuclear reactions stop. This is how we stop a nuclear reactor. Okay, my dear students, so this is Professor One. Thanks for watching the video, and please share the video with all your friends and subscribe the YouTube channel. All the best. Bye.